Hello students. So generally we start our class with a very positive note, and this is what I thought I'll share with you. The first rule of focus is this: wherever you are, be there, because aisa na ho that you are in a movie and you're thinking about your study, and when you're studying you're thinking about a movie देख रहे हैं तो भाई full on movie enjoy करेंगे, पढ़ाई कर रहे हैं तो full on पढ़ाई करेंगे, ये है ना, एक बार में एक काम करेंगे. So wherever you are, be there. Okay, don't let your mind wander off. Okay, be present, be mentally present. You are physically present but be mentally present. अभी हम class start करेंगे, you are with your laptop or an iPad or a mobile. Sit in a well ventilated room or some good nice quiet place with a copy and a pen, and besides being physically present, be mentally present also, right? Don't just pause the video and go to YouTube and just seeing some songs. No, nothing. We are going to study, right? So please be physically and mentally present both. So we are continuing with the chapter of biomolecules, right? And today the subtopic which we are going to do is enzymes. And in the enzymes, we are going to do a very important thing, that is Michaelis-Menten Equation. बहुत बच्चे तो इसको छोड़ ही देते हैं, उनको समझ ही नहीं आती. क्यों नहीं समझ आती? क्योंकि वो इसको they don't try to derive it. So we will derive it and we will see the various assumptions of these equations, and we will try to plot it on a graph. And we'll also do the Lineweaver Burk plot, right? And this is what we are going to do today. So basically, this is what we are going to do today. And in the next session, we will be doing what? We'll be doing, not today, but in the next section, we will be doing enzyme inhibition. So now you have, you have the knowledge of two classes. The first class for enzymes is for Michaelis-Menten equation, and the second class is for enzyme inhibition. Right, so let us start with the Michaelis-Menten equation. Okay, so the first thing that we should know in this is enzyme kinetics. What is enzyme kinetics and what is steady state assumption? ये दोनों बड़ा important है. Steady state assumption, this is very important. So does the steady state assumption says that enzyme plus substrate, enzyme substrate complex, enzyme plus product. लिख लेते हैं enzyme plus substrate, enzyme substrate complex. Yes is what? Enzyme substrate complex. इसको याद रखना, जब derive करेंगे तो बहुत बार use करेंगे. And enzyme plus product. So now we know what is E plus S. So this constant, this forward, when this reaction, the rate of formation of enzyme complex, we can denote it with a constant K1, and this enzyme complex back into enzyme plus substrate, we can denote it with K minus 1. And this enzyme substrate dissociating into enzyme plus product, we can denote this rate as K2. Right, so the K1 is what? The rate at which E plus S is forming into enzyme substrate complex, right? So this you should know. So now what is this steady state assumption stating? This is stating that the rate of formation is equal to rate of dissociation. Matlab, rate of formation of enzyme substrate complex. Now, from now on, I will write ES is equal to rate of dissociation. D is what? D is dissociation. The rate of dissociation of, or the rate of dissociation into enzyme and product. And where is this equilibrium reach? Suppose अगर हम ऐसे बनाते हैं तो enzyme plus complex कम हो रहा है because enzyme plus substrate mix हो रहा है. This is becoming less, and enzyme plus product dissociate हो रहा है. Enzyme plus ये इसमें dissociate हो रहा है, तो enzyme and product बढ़ रहा है. So ये क्या हो गया? Enzyme plus substrate और ये enzyme plus product, क्योंकि ये enzyme plus product में क्या हो रहा है? Dissociate हो रहा है. तो ये हो गया आपका स्टेडी स्टेट इक्विलिब्रियम की जो रेट, और दिस इज वेरी इंपॉर्टेंट, द रेट ऑफ फॉर्मेशन ऑफ एंजाइम सबस्ट्रेट इज इक्वल टू द रेट ऑफ डिसोसिएशन ऑफ एंजाइम एंड प्रोडक्ट. ये बात समझ में आ रही है कि एंजाइम और सबस्ट्रेट मिक्स हो रहे हैं, ठीक है, वो बन रहे हैं, किसमें बन रहे हैं? एंजाइम सबस्ट्रेट कॉम्प्लेक्स में बन रहे हैं, और ये ब्रेक हो रहा है किसमें? ये ब्रेक हो रहा है एंजाइम और प्रोडक्ट में, डिसोसिएट हो रहा है. तो ये हो रहा है और यहाँ पे डिसोसिएट हो रहा है, राइट? सो दिस इज इंपॉर्टेंट, दिस इज वेरी वेरी इंपॉर्टेंट, द स्टेडी स्टेट assumption. Now let us see what have we written. So we wrote rate of formation is equal to rate of dissociation, right? This is the steady state equilibrium assumption. Okay. अब हम देखते हैं हमने क्या लिखा था. हमने लिखा था E plus S K1 K minus 1 enzyme substrate complex is equal to enzyme plus product. अब हम रेट ऑफ फॉर्मेशन को अगर देखें तो रेट ऑफ फॉर्मेशन तो इसमें हम क्या देख सकते हैं? We can see that K1 enzyme substrate is equal to K minus 1 plus K2 E and S, right? So इसमें हमने क्या देखा कि we saw that, sorry, this should be K minus 1 E and S. I'll write it again. It's got very clumsily. I wrote it in a very clumsy manner, so I'll write it again. So rate of formation is equal to rate of dissociation. Okay. Rate of formation is equal to rate of dissociation. इसमें समझ में आया हमें? Okay, so this is the rate of formation is equal to rate of dissociation. This is a very important formula. From this we'll derive this Km, that is the Michaelis constant. अब हम एक बात और समझ लेते हैं कि total enzyme is what? Free enzyme plus the enzyme that is bound to substrate, right? ये तो बहुत इजी बात है. टोटल एंजाइम क्या होगा? टोटल एंजाइम होगा जो फ्री होगा एंड जो सबस्ट्रेट से बाउंड होगा, राइट? तो टोटल एंजाइम ये हो गया, फ्री एंजाइम निकल आया, ठीक है? व्हाट इज द फ्री एंजाइम? टोटल एंजाइम माइनस एंजाइम से जो लगा हुआ है, राइट? दिस इज E एंड दिस इज ES, राइट? तो हमारा क्या निकल आया? E निकल आया. व्हाट इज E? E इज टोटल एंजाइम minus bound to, and this is very logical also, right? टोटल एंजाइम में से जो सबस्ट्रेट से बाउंड है और वो फ्री एंजाइम, दिस इज फ्री एंजाइम. दिस इज वेरी लॉजिकल आल्सो. नाउ वी विल पुट दिस in this reaction. Let us see क्या बन जाता है. तो K1, अब E की जगह हमने ये लिख दिया. ठीक है, E की जगह हमने ये लिख दिया यहाँ पे. ओके, और ये सबस्ट्रेट वैसे का वैसे ही इज इक्वल टू K-1 ES प्लस K2 ES. ओके, ये हो गया. अब इसमें से हम क्या कर सकते हैं, K1 ET S माइनस K1 ES. बेसिकली क्या किया, ब्रैकेट खोल दिया और कुछ भी नहीं करा, है ना. एंड अब यहाँ पे ES को हमने कॉमन ले लिया. ठीक है, और K-1 प्लस K2. यहाँ तक समझ में आ गया. बेसिक सिंपल मैथ्स कर रहे हैं. ठीक है, चलो अब आगे देखते हैं. अब एक Km होता है, दिस इज K-1 प्लस K2 अपॉन K1. ये क्या होता है, दिस इज an assumption that we make. What is this? This is an important assumption that we are making. So we don't have to prove this, we have to plug this in this. ठीक है, तो this is what is Km? This is Michaelis constant. Michaelis constant. So ये तो constant है, is what? It is equal to rate of dissociation upon rate of formation, right? Rate of formation. तो ये समझ में आ गया. Km Michaelis constant क्या होता है, rate of dissociation upon rate of formation. Easy to understand. ठीक है, अब let's see, we will put this in this. तो क्या होगा, it will become K1 T S minus enzyme substrate upon K1 is equal to, basic simple maths hai. I am not doing anything very difficult maths. ठीक है, you can see this. बेसिकली हमने क्या किया, K1 से डिवाइड कर दिया है और कुछ दोनों साइड हमने K1 से डिवाइड कर दिया. ठीक है, दोनों ये चीज लिखी हुई थी, इसको दोनों साइड को K1 से डिवाइड कर दिया. देन when you'll do it with your own hands, it will look very easy because it is not very difficult. Now see what I am doing, right? ये cancel हो गया था. And this is what basically अभी हमने पढ़ा था, Michaelis constant. इसकी जगह हमने ये लिख दिया और अब दोनों साइड हमने क्या किया है, ये एडिशन कर दिया है. ठीक है, अब लेट्स सी क्या हो सकता है. तो ET S, ये कैंसिल आउट हो गया, इज इक्वल टू दिस एंड दिस. ओके, चलो अभी हमने क्या किया, let me make this clear. I hope you are getting this much. ठीक है, अब हमने क्या किया, see, when we'll do it, no, it will be very, very, very awesome. Okay, let me write one more line, then it will be very easy for you. ES को बाहर लिया and constant plus substrate upon constant plus substrate, right? Hope you are understanding. And here also, because both sides करना होगा. This got cancelled. Okay, अभी क्या आ गया, ET S upon Km plus S. This is what? This is enzyme substrate, right? अब ये एक चीज हमने अभी डिराइव करी. Remember this. Okay. Now we'll assume one more thing, that V naught initial velocity is equal to K naught ES, or ES is equal to V naught upon K2. And what is V naught? V naught is equal to initial velocity, right? This is an assumption. The assumptions I'm writing it in red. यहाँ पे हमने assumption लिया था ये Michaelis constant वाला, and again here this is an assumption, right? This is again an assumption. I hope you are enjoying derivation. तो वैसे भी always बहुत interesting होते. Let's plug this here. So what will we get? We will get V naught upon K2 is equal to ET S upon Km plus S, right? अभी इसको क्या लिख सकते हैं? V naught is equal to K2 ET S upon Km plus S. यहां तक you are with me? No problem, right? अब let's see. अभी ये assumption आपको हमेशा याद रखना है. V naught is equal to K2 ES, ES, ठीक है? V naught is equal to K naught ES. I'll write it again here. V naught is equal to K2 ES. Okay, this is an assumption which we are, ठीक है? तो now we'll see what is Vmax. Vmax is a point. Vmax is a point where all enzyme substrate complex is formed and no free enzyme is left. ठीक है? Vmax क्या होता है? जब पूरा जो एंजाइम प्लस सबस्ट्रेट बना रहे थे तो ये पूरा बनके एंजाइम प्लस सबस्ट्रेट पूरा बन गया और अब कोई भी फ्री एंजाइम नहीं बचा है. ठीक है? ये हो जाता है हमारा Vmax. ये क्या हो गया? Vmax में क्या होता है? एंजाइम सबस्ट्रेट पूरा बन गया एंड नो फ्री एंजाइम. जो फ्री एंजाइम है दैट इज नॉट लेफ्ट. ओके, सो दैट इज व्हाट दैट इज फ्री, दैट इज Vmax. अब Vmax is equal to K2 ET. Okay, and V naught is equal to Vmax substrate upon Km plus S. ये समझ में आया आपको? आप इसको एक बार अच्छे से ये वाला फॉर्मूला देखिए. V naught is equal to K2 ETS upon Km plus X, right? अब V naught क्या है? V naught is equal to K2 ES, right? और Vmax is equal to K2 ET. तो हमने इसमें प्लग इन करा तो V naught क्या बन गया? V naught आ गया Vmax substrate upon Km plus X. And this is what? This is our Michaelis-Menten equation. This is what? This is our Michaelis-Menten equation, right? So we got it, we derived it. Not a very very difficult thing to derive. It's actually very interesting, right? Where V naught is equal to what? Where V naught is equal to initial velocity. Where V naught is, you derive and you will enjoy it. This is the maximum velocity, and what, you know, Km is equal to the Michaelis constant, and S is the substrate, right? Now let us do something more. S is what? S is the substrate concentration, right? S is the substrate concentration. Okay, this much is clear to you, right? We have got the Michaelis-Menten equation, and this is very, 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 very important. Okay, now let us see one more thing. Now let us see some more thing. we say that the V naught is equal to V max upon 2. Remember? So V max upon 2 is equal to V max S upon Km plus S, right? This is what? This is the Michaelis-Menten equation. So 2V max S substrate concentration upon V max is equal to max Km plus substrate concentration upon V max, right? I assume that since you are doing NEET preparation, you might be understanding what I am doing. It's not very difficult mathematics that I am doing, right? So 2 substrate minus 1 substrate is equal to Km. It means that substrate concentration is equal to Km is equal to V max upon 2. When it is half V, I should write it as half V max. It says the same thing, but it's a better way to write. So when V max upon 2, then the Km is equal to substrate concentration, right? This is what this equation is saying. Right now, let us write it, right? What is Km? Michaelis concentration. Michaelis constant or Km is the substrate concentration, right? Is the substrate concentration when the reaction is 1/2 of V max, and it is constant. It is constant for a given enzyme. It is constant for a given enzyme and is independent of substrate or enzyme concentration, right? So we have derived it and we have seen what is this line saying. It is the substrate concentration. It is the substrate concentration when the reaction is 1/2 of V max. And this is what? This is Michaelis constant Km. Okay. So what is this basically saying? If we want to say what is it saying, when it is basically showing the affinity. It is basically showing the affinity of substrate. Means when we say it is basically showing the affinity of substrate, it means how much substrate, कितना substrate एक enzyme ले सकता है, उससे जुड़ सकता है. How much substrate an enzyme can take. तो मतलब different enzymes की different affinity हो सकती है same substrate को लेके. ठीक है, एग्जाम्पल लेते हैं, एक एग्जाम्पल लेके देखते हैं. 2 एंजाइम्स हैं, 2 एंजाइम हैं और वो सेम फंक्शन परफॉर्म करते हैं. ठीक है, 2 एंजाइम सेम फंक्शन परफॉर्म करते हैं. कौन कौन से एंजाइम है वो? एक हेक्सोकाइनेज एंजाइम है, ठीक है, एंड इट इज फाउंड इन मसल, एंड दिस ग्लूकोकाइनेज इट इज फाउंड इन लिवर. ठीक है, बट इनकी Km वैल्यू जो है वो डिफरेंट है. बेसिकली ये क्या है? ये आइसोजाइम्स हैं, बट इनकी Km वैल्यू डिफरेंट. विल नॉट गेट इन मच डिटेल, नहीं तो इट विल बी टू मच. इनमें डिफरेंस क्या है? इनकी ये हैव they have different affinity for substrate and the amount of substrate that they can take on. ठीक है, they are isozymes but they have different affinity for substrate and the amount of substrate they can take on. राइट। तो ये हमने समझ लिया माइकलिस-मेंटन इक्वेशन के बारे में, राइट। लेट अस सी नाउ व्हाट, अब हम इसको क्या करेंगे, नाउ वी विल ट्राई टू प्लॉट अ ग्राफ। माइकलिस-मेंटन इक्वेशन अगर हम प्लॉट करते हैं, इट जनरेट्स अ हाइपरबोला, राइट। अब इसमें कैसा होगा ये ग्राफ, चलो बना के देख लेते हैं। दिस इज द ग्राफ, ठीक है। ये हाइपरबोला इस तरीके का बनेगा, जिसमें ऑन द एक्स एक्सिस देयर इज सबस्ट्रेट concentration and on this y axis we have the initial velocity Vmax, V naught, and on this point we are showing Vmax upon 2. okay, चलो इसमें हमने क्या देखा, दैट जो इनिशियल रिएक्शन होता है, द इनिशियल रिएक्शन वेलोसिटी varies with substrate concentration. When the substrate concentration is low at any given point of time, the number of collisions between enzyme, जब substrate कम होगा तो enzyme और substrate में जो collisions हो रहे हैं, जो आपस में collisions हो रहे हैं, वो भी कम होंगे. When substrate is कम, obviously this is so logical, तो enzyme substrate collisions ज्यादा होंगे कम होंगे, जब कोई चीज कम है तो कम लड़ेगी ना, तो enzyme substrate collisions भी कम होंगे. when the substrate concentration is low at any given point of time, the number of collisions is less, and when the substrate concentration is high, तो enzyme substrate collisions क्या होंगे, when the enzymes collide with the substrate molecules more rapidly, अब ये ज्यादा collide होने लगेंगे, and this collision more rapidly than they can be converted to product. इसमें क्या हो रहा है, enzyme substrate collisions बहुत जल्दी हो रहे हैं, प्रोडक्ट नहीं बन पा रहा है, but enzyme substrate collisions इतने हो रहे हैं कि प्रोडक्ट तक नहीं बन पा रहे हैं. So with the increase in substrate concentration, the enzyme reaches what? Enzyme reaches a state of saturation. The enzyme reaches it cannot take more substrate. The enzyme cannot take more substrate. Why? Because all the enzyme reaches a state of saturation. Let's try to understand क्या हुआ इसमें. इसमें क्या हुआ कि all the substrate molecules, जो substrate molecules थे, जितने भी substrate molecules थे, उनको क्या हुआ, all the substrate molecules have been used up, and no free enzyme is there to bind what? To the additional substrate. ठीक है, इसमें क्या हुआ, at this point, this is what velocity, this point is the Vmax or the maximum velocity, जिसमें desired product बन गया है. We have got what? We have got the desired product. अब और product नहीं बन सकता. We cannot make no more product. अब क्या होगा, there will be no more product. इसके बाद there will be no more product. So इसमें हमने क्या देखा, Vmax पे, Vmax, this is what? This is V max. V max पे हमने क्या देखा? There are no free enzymes. What happens on V max? No free enzymes. And all the no free enzymes are left. Why? Because all enzymes are occupied at their maximum velocity. ठीक है? All enzymes are occupied. ठीक है? So this is what is Michaelis-Menten equation. Now we said we'll also study about what? We'll also study about Lineweaver Burk plot. So इसमें क्या है? जो ये हमने पढ़ा this Michaelis constant, इसमें एक गड़बड़ क्या थी? The plot of V versus X was what? It was not linear. It was what? It was a hyperbola. और hyperbola बनाने के लिए हमें and for determining the values of Vmax and Km बहुत सारे हमें plot करने पड़ते हैं points. So बहुत सारे एक linearizations model दिए गए और सबसे mostly accepted model है Lineweaver Burk plot. Basically काम आसान करने के लिए एक linear model दिया गया जिसको हमने कह दिया Lineweaver Burk plot. अब अगर हम रेसिप्रोकल ऑफ द वेलोसिटी और सबस्ट्रेट को ले ले, बेसिकली जो हमने ये बनाया है ये हाइपरबोला, इसको हम रेसिप्रोकल कर दे, इसको उल्टा कर दे तो क्या बन जाएगा? लाइनवीवर बर्क प्लॉट. इसमें हम क्या कर रहे हैं? इफ द रेसिप्रोकल्स ऑफ वेलोसिटी एंड सबस्ट्रेट कॉन्सेंट्रेशन are plotted against one another, जैसे कि हमें लाइनवीवर और डीन बर्क ने दिया था, तो एक्ट क्या होगा? बेसिकली क्या हो जाएगा? ये इजी हो जाएगा हमारी स्टडी करने के लिए. जब ये हमने किया तो क्या हो गया? जो हाइपरबोला था, व्हाट इट विल बिकम? व्हाट इट विल बिकम? अ स्ट्रेट लाइन. इट विल बिकम अ स्ट्रेट लाइन, राइट? तो इसके हम वो भी देख लेते हैं. इसमें हर जगह बुक में क्या लिखा रहता है? x क्या है, y क्या है, स्लोप क्या है. तो थोड़ा सा we'll just take an idea. v naught is equal to v max. This we already know, right? This is the Michaelis-Menten equation. So 1 upon v naught is equal to km plus s upon v max s. ठीक है? तो 1 upon v naught is equal to km upon v max x plus s upon v max s. ये कट करा. So 1 upon v naught is equal to km v max s 1 upon 1 upon s plus 1 upon v max. Just another way I'm writing this. So this is basically what? Y is equal to m x plus b. So this is what? This is the y m x plus b. So m is what? M is the slope and b is what? B is the intercept. तो basically हमने क्या बोला था कि inverse of reciprocals of what? Reciprocals of velocity and s are plotted, right? Velocity, reciprocals of velocity and substrate concentrations are plotted. So this is what we are going to do, right? So तो अब हम इसको जब प्लॉट करते हैं तो लेट अस सी, इसको हम प्लॉट करेंगे. तो the kind of plot you'll get will be like this, right? And what is this? This is 1 by v. This is minus 1 upon km, and this is 1 upon substrate concentration, right? And these are the various points that we get. Oh, what is happening? Okay, so we get these points. And what is the slope? The slope is, we just studied, the slope is Km upon V max. So what is this? The slope Km upon V max. This M is equal, slope is Km upon V max. Y is what? In this. X is what? This. And B is what? Right? Chalo, you see this for some time. अब इससे क्या हुआ? Km और Vmax की हमें फटाफट वैल्यू मिल गई लीनियरी. ठीक है? So this becomes a relatively easier thing to study. तो इसका क्या नाम है? इसका नाम है Lineweaver Burk plot. So this is what completes our today's video. Let us see what we did today. Right. So what we in the chapter of biomolecules, we studied the Michaelis-Menten equation. We derived it. We saw the assumptions. We drew the graph. We saw the linear Burk plot. We saw the graph. So in the next video, we'll be doing the enzyme inhibition. So in the Michaelis-Menten equation, we studied about enzyme kinetics, and we saw what is steady state assumption. What is steady state assumption? That the rate of formation is equal to rate of dissociation. Means enzyme plus substrate, this is equal to this rate of dissociation, because ये form हो रहा है और ये finally इसमें dissociate हो रहा है. So the rate of formation of enzyme substrate complex is equal to the rate of dissociation of enzyme and product. ठीक है? So basically enzyme plus substrate कम हो रहा है और enzyme plus product बढ़ रहा है क्योंकि ये dissociate हो रहा है. Right? So the rate of, फिर हमने इसको derive करा. You can see the derivation and do it on your own. Right? So this was the K1 is the constant where E plus S is forming into enzyme substrate complex, and K minus 1 is the constant where this is this can be dissociated into enzyme plus substrate, and K2 again is the constant of dissociation, right? So we did this. This is a very important equation. Now we saw that the total enzyme is equal to free enzyme plus the enzyme that is bound to substrate. Okay, then we plugged this into this, and then we got what? We got these equations, and from there we plugged this Michaelis constant, and then we solved it. This is all the solution. You can see you have to do it with your own hands. Then we again saw this assumption. Okay, we saw what is Vmax, and then we described the Michaelis-Menten equation, and then we saw the substrate concentration when the reaction is 1/2 of the Vmax is equal to Km. Then we saw what does it means, the affinity for substrate. Then we saw the examples of isozymes, and then we plotted it, right? And then we saw what is the state of saturation and the maximum velocity, and then we draw the Lineweaver Burk plot. So it was a very nice thing. It was a very exciting class, and my charger fell down, and it was a very nice and an interesting class. I really enjoyed it. It was a bit difficult, a bit monotonous, but you have to study it because it is very, very important. Next class will be very exciting in the inhibition, and this class was more of equations and mathematics, so you have to take a pen and paper and solve it. So I hope it was a bit monotonous, but it was important, and you have to learn this. It is very, very important. So guys, bye bye and thank you. Have fun and stay safe and study hard.